Hello, I am going to present our 5th year project, which involves analyzing the non-linearities of a low frequency loudspeaker. The aims of the project were to list the physical causes of the non-linearities, to measure the distortion on the loudspeakers, which is an indicator of non-linearity, and to make the link between cause and effect. First of all, I'm going to tell you a bit about how a loudspeaker works. In a speaker, you have a crucial interplay of components. At its core, it's a membrane or a cone, typically made of materials like paper or plastic. Attached to this is a mobile coil, usually copper wire, wound around a lightweight structure. Surrounding the coil is a fixed magnet with a specific polarity. The coil, suspended within this magnetic field by a flexible suspension, is free to move forward and backward, which basically create the sounds. So, there are therefore several physical aspects to this system. The Thielen-Small model is a model commonly used in electroacoustics to represent the linear operation of a loudspeaker through an electrical diagram. 7 parameters linked to electrical, mechanical, and acoustics physics influence the non-linear behavior of a loudspeaker. So the aim of our project was to quantify which of these 7 parameters was most likely to influence the non-linear behavior of a loudspeaker. But what is non-linearity? In acoustics, non-linearity is the appearance of harmonics in a pure signal that originally contained a single frequency line. Quantifying the non-linearity of a system therefore comes down to measuring the THD, which stands for total harmonic distortion. For example, in this graph representing the frequency response of a loudspeaker, we can see that when we send a chirp input signal corresponding to a frequency sweep, we see lines appearing at different multiples of the frequency sent. Then we carried out comparative measurements between a high-fidelity loudspeaker and an old loudspeaker likely to present non-linearities. We actually obtained a higher THD for the older speaker, which presents almost 20 decibels of additional distortion. After numerous measurements and simulations, we conclude that the main non-linearity factors were the parameters linked directly to the input signal, such as frequency and amplitude. Then the mechanical parameters, called KMS, and the BL factor linked to the coil's magnetic field. Thank you a lot for your listening, and goodbye!